Here we go. We have a question, split the array. So you have given an array of integers and our task is to count the number of ways to split the given array elements into two distinct groups such that XOR of elements of each group is equal. And note here is the answer could be very large, so print it using the modulus. We have given this example. In this example there are three ways. One is this, so XOR of this group is 1, XOR of this group is also 1. Then another way is this, so XOR of this group is 2, XOR of this group is also 2. Another way is this, so XOR is 3 here and XOR is 3 here also. So there are in total 3 ways, and in this answer is not possible. So let's build the approach. So let's say we have array 1, 2 and 3. So 1 is this, then 2, sorry, 1 is not this, 1 is this, then 2 is this, then 3 is this. So if I do XOR, we got 0. So if I got 0 means there are even number of ones, because in XOR if I do 0 1 we got 1, if I do 0 1 we got 1, if I do 1 1 we got 0, if I do 0 0 we got 0, means there are even number of ones, either 0 2 4 8. So you got my point. So let's try to understand what we have to do. If we got this answer, let's say this is answer, or let's say this is XOR. If XOR of all the elements, if XOR is not equal to 0, means somewhere here, so let's say this is 3 also, so we got 1, so this is this, and here there are odd number of ones, so we cannot divide into group 1 and group 2, we cannot divide. So XOR is equal in both groups, we cannot divide because there are odd number of ones. So if there are even number of ones, only then we can divide. So if I got non-zero, so this is 0 1. If XOR is not equal to 0, means we cannot divide, so total number of ways is 0 here. So let's say we have 2 and this is 0, so we got our answer as 0. So now let's find out how many ways can we divide. So let's say we have group 1 and group 2. Just bear with me, I'm gonna write all the groups. First is this, then another one is this, then is this. We can take subsets, another one is this, then let's say 1 2, here is 3, let's say 1 3, and here is 2, let's say 2 3, and here is 1, and let's take all values, and here is so we have to divide into group 1 and group 2. This condition holds and XOR is 0. We know XOR is 0, so there are multiple ways to divide. This is not valid, so let's say this is not valid, and this is also not valid because here it is empty and here it is also empty. So how many total ways are there? Here? So a value can be included, a value is not included, a value is included, we are ignoring this case. So here 1 is included and here 2 is included, here 3 is included. So we have two choices, either we can take value or we can not take value. So we have this. For this we have two choices, either we can take or we will not take. So here we have also two choices, here we have also two choices, so which include this and this case also, which include this case and this case. So we have these cases, but this case, empty case, and this empty case is not valid. So just write minus 2. Array length is 3, so we can write 2 raised to power n minus 2. So let's take 2 outside. We have 2 and minus 1 minus 2 minus 1, sorry. And here we just ignored this case and we just ignored this case. But if you observe, 2 3 is here and 2 3 is here, which means this subset has one group as 1 and another group as 2 3, and this group also has 1 and 2 3. So let's find out duplicate groups. So 1 2 3. So here this is duplicate, then 1 3 here, 1 3 here, so this is also duplicate, then 1 2 here, so this is also duplicate, means half of the subset is duplicate. So we just gonna divide with 2, we just gonna divide with 2, we just gonna divide with 2. So we are left with 2 raised to power n minus 1 minus 1. So we have this case, means a raised to power b. So you can solve it using power function, but I observed that we don't need modulus. So we have to do this. We can write this thing into left shift. So if I do 1 with 1, we got this. If I have 0, then we got this. If I have 2, then we got this. If I have 3, then we got this. So this is same. So what we can do, 1 left shift and minus 1. So this is our answer, but we have also minus 1, so we just gonna write minus 1. So this thing and this thing is same, but this is faster because this work on bits. So let's try to code this. We first have XOR and n. Let's do the XOR of all the elements. If XOR is not 0, return 0, else we can do this, means 2 raised to power n minus 1 minus 1. So let's give it a try. And thank you all for watching.